In my lecture 2, I explained about the rational numbers and its decimal expansion. Now, you had seen how to convert the rational number into decimal if it provides you terminating decimal. Now we are coming for the next point, irrational numbers. Let's see. Irrational numbers. How to define irrational numbers? The same way you can say the number which cannot be written in form of p upon q and q is not equal to 0. You can say simply irrational numbers. Now, all decimal expansions which are non-repeating, non-terminating and non-repeating decimal expansions are also irrational numbers. And one more thing you can observe, all prime numbers, if we find the roots of those prime numbers, the result is irrational. Like 2 is a prime number, so under root 2 is irrational, or cube root 2 is irrational. 3 is prime number, under root 3, cube root 3, fourth root 3, all are prime numbers, irrational numbers. 5 is prime number, under root 5, cube root 5, fourth root 5 is irrational numbers. So all these numbers are irrational numbers. Now sometimes you are given to prove that under root 2 is irrational, or under root 3 is irrational, or under root 5 is irrational. So how to prove that under root 2 or under root 3 or under root 5 irrational number? For rational number we have logical method, but for irrational number we don't have any particular method to prove. And whenever we don't have any idea to prove, we use contradiction method. Contradiction method means the statement which is opposed. So let's see how to prove irrational numbers. Let me write, show that under root 2 is irrational numbers. Irrational numbers. So we don't have any idea, as I told. So what to do? We use contradiction method. Means we will suppose that under root 2 is not irrational. Means under root 2 is a rational number, and we will apply the rules for the rational number. And if somewhere the rule fails, rules fails, it means our supposition is wrong. Then finally we say that under root 2 is not a rational number but irrational. Let's see how to solve. We write, let under root 2 is a rational number. Under root 2 is a rational number. And if it is a rational number, then we can write this in form of p upon q or a upon b. Therefore, we can write under root 2 is equal to p upon q, and q is not equal to 0. P and q are co-prime integers or co-primes. P and q are co-primes. Now we have considered that under root 2 is rational number. Now I told in the beginning of my previous lecture that when we apply the law, the rule, then on rational numbers we get the result rational. Like sum of two rational number is rational number, difference of two rational number is rational number. In the same way, square of rational number is rational number. So since it is a single number, so we can apply squaring this, squaring both sides. What we have, 2 is equal to p square upon q square, or cross multiply p square is equal to 2q square. Let this is an equation. Now one fact I am going to tell you. If a number is a factor of any perfect square number, if a number is factor of any perfect square number, then the same number is also the factor of its square root. Let me explain once again what I am telling. If a number is factor of any perfect square number, then the same number is the factor of its square root. Let's see. Suppose 5 is factor of 25, then 5 is also factor of root 25, that is 5. What I told, if 5 is factor of this perfect square number 25, then 5 is also the factor of its square root, that is 5. Or suppose I am writing 2 is factor of 16, then 2 is also factor of root 16, that is 4. What I told, 2 is the factor of this perfect square number 16, then 2 is also the factor of root 16, that is 4. So you have to remember this. If a number is factor of any perfect square number, the same number is the factor of its square root. Let's see. This was the example. Now here, see this. P square is equal to 2q square. What we see? We see that 2 is factor of p square. P square is perfect number, perfect square number. So 2 is factor of p square. Then according to rule, 2 is also the factor of p. We write, since 2 is factor of p square, then 2 is also factor of p. 2 is also factor of p. Let this be an equation. But you may be thinking that this may be by chance. This may be by chance. So we can choose any other number in place of p, any other arbitrary number, like I am telling you. See this side. Let p is equal to 2r, another number r, and since it is under root 2, so multiple is 2r. If under root 3, multiple of 3r. If under root 5, multiple of 5r, and so on. Now squaring. Squaring. P square is equal to 4r square. Now putting this value in equation number 1. Put it. Putting this in equation 1. So what we have, 4r square is equal to 2q square. This 2 goes 2 times, means we have q square is equal to 2r square. Q square is equal to 2r square. What does it mean? Again 2 is the factor of q square. 2 is the factor of q square. Then 2 is also the factor of q, like this. So we write here 2 is a factor of q square, then 2 is also factor of q. Let this is another equation. Read this equation first, you will star first and star second. What we observe? Here 2 is a factor of p, and here 2 is also factor of q. So clearly you can see that 2 is factor of both p and q. We write from star 1 and star 2. 2 is common factor of p and q. Now come to the definition of rational number. What was the definition of rational number? It was there that if a number which can be written in form of p upon q, q is not equal to 0, p and q are co-primes. P upon q is rational number if and only if p and q are co-primes. Here we have 2 is factor of p and q. So can you say that p and q are co-primes? Of course not. Means therefore p and q are not co-primes. Co-primes. I am writing here, you can see p and q are not co-primes. So what we have observed? We had observed that p and q are co-primes. Therefore, this statement is opposed. Means this is contradiction. Therefore, we write there is a contradiction. So, p upon q is irrational or under root 2 is irrational. Got it? This is how we prove that under root 2 is irrational number, or you can be given under root 3 is irrational number, or you can prove under root 5 is irrational number, or under root 7 irrational number, or under root 11. Means root of any prime number you can find using this statement only. Suppose one question is given in your exercise, prove that under root 5 is irrational number. So this statement is same. Just you will write under root 5 everywhere. Wherever you are having 2, you can write 5. And other statements are same. You can get the result. Got it? Now, coming to properties of irrational numbers, algebra of irrational numbers you can say, means when we add two irrational numbers, the result is irrational. When we subtract two irrational number, the result is irrational number. When we multiply two different irrational numbers, not same irrational number, I am talking about two different irrational numbers, the result is irrational. When we divide two different irrational numbers, the quotient is irrational. I am talking about different irrational number. When you will talk about same irrational number, the result is rational. Irrational upon irrational, result is rational. I am talking about different irrational numbers. So this is all about two irrational numbers. Operation on two irrational numbers. Now let's see operation on two numbers in which one is rational and other is irrational. Means sum of a rational number and an irrational number is always an irrational number. Difference of a rational number and an irrational number is an irrational number. Product of a rational number and an irrational number is an irrational number. Quotient of a rational number and irrational number is irrational number. So this thing you have to keep in mind. Sometimes you get a question to show that sum of a rational number and an irrational number is irrational, or difference of a rational number and an irrational number is irrational. So how to show it? Just I am rubbing the board and showing this. See, show that question is Question is, show that 2 plus under root 3 is an irrational number. See, 2 is a rational number, root 3 is an irrational number. Both 2 plus root 3 is an irrational number. We have to show it. Very simple method. We have two methods to solve for a rational and irrational number. See, by the same method, by contradiction method, we will suppose that this is a rational number. Let see the first method, the smallest method. Let 2 plus under root 3 is equal to x is a rational number. Now see, we have total 2 plus root 3 is equal to x and x is a rational number. For solving this, what to do? 2 is rational and this side x is rational. Send this rational number towards rational number. What to do? Under root 3 is equal to x minus 2. X minus 2. See, what is it? X is rational, minus 2 is rational. Difference of two rational number is rational number in right side. And what is in left side? Under root 3. Right now, in the previous example, we have seen that under root 2 is irrational, under root 3 is irrational, under root 5 is irrational. So, under root 3 is irrational. So, the value of an irrational number never be a rational number. So, this contradicts. So, what we write? Here, we write here x minus 2 is rational, but under root 3 is irrational, which contradicts. Therefore, we can say 2 plus under root 3 is irrational number. Simply by this method we can show it. Now let's see another method. Second method. The same question can be solved by another method. Again you will suppose that 2 plus under root 3 is not irrational number, means it is rational number. We write let 2 plus under root 3 is equal to x is rational number. In place of this you can write p upon q also, a upon b also. So if it is rational number, then square of rational number is rational number. Squaring both sides. So what we have, see, this is binomial a plus b whole square. We have 4 plus 3 plus 4 under root 3 is equal to x square. 4 plus 3 7. 7 plus 4 under root 3 is equal to x square. See, 7 is rational. X square is rational because x is rational, so square is rational. So x square is rational. Send this rational towards rational. So what we have, 4 under root 3 is equal to x square minus 7. Come to this point. Again in left side we have 4 is rational. So send this for this side. So under root 3 is equal to x square minus 7 upon 4. Now come to the point in right side. X is a rational number we have assumed. So x square is rational. 7 is rational number. So x square minus 7 is rational. Why I told? Difference of two rational number is rational number. Divided by 4. 4 is rational. Quotient of two rational number is rational. Means finally we observe that x square minus 7 upon 4 is rational number. So we write since x square minus 7 upon 4 is rational, but under root 3 is not rational. Under root 3 is not rational. Means therefore this contradicts the statement. Means the value of any irrational number never be equal to rational. So if our statement is contradict, it means we have assumed that this is rational number. Now it is opposed. Means what can we say? 2 plus under root 3 is irrational. Irrational. This is how we can prove this. Now, one more thing. This is sum of a rational number and an irrational number. You can use the same process if difference of a rational number and an irrational number. So we have shown two methods. One is direct method, assuming that irrational number is rational number, shift the rational part towards rational part, and one side keeping irrational part and show that irrational part is never equal to rational part. Another method, by taking the same as rational number, squaring that side, and then we get the same result. Now we come to the point, if we have sum of two irrational number is irrational, or difference of two irrational number is irrational number. So how to solve this? Let's see. You will have a question. I am writing. See, I am writing one question. Question is, show that under root 5 minus under root 2 is an irrational number. An irrational number. We have to show this. It may be plus also, difference of two irrational number or sum of two irrational numbers. The same method by contradiction. I told in the beginning there is no genuine method for irrational, so we use contradiction method to show this kind of numbers. Let's see. We have let under root 5 minus under root 2 is equal to x is a rational number. Rational number. And if this is a rational number, then square of rational number is again rational number. So squaring this, so we have C, a square 5 plus b square 2 minus 2 under root 5 into under root 2 is equal to x square. We have 7 minus 2 under root 10 is equal to x square. X is rational number, so its square is rational number. 7 is rational number, send rational number towards rational number. What we have, minus 2 under root 10 is equal to x square minus 7, and under root 10 is equal to x square minus 7 upon minus 2, or we can write 7 minus x square by 2 by dividing this by minus sign. So we have 7 minus x square by 2. Now let's see. 7 is a rational number, minus x square is a rational number. So 7 minus x square is rational number, upon 2 is a rational number. So quotient of a rational number by another rational number is always rational number. Means 7 minus x square upon 2 is rational. So what we have, under root 10 is equal to 7 minus x square upon 2. So 7 minus x square upon 2, since 7 minus x square upon 2 is rational, but under root 10 is not. Means under root 10 is not a rational number. So this statement again contradicts this statement we had assumed that this value is a rational number. Now I'm getting this is rational number and this one is irrational number. So there is a contradiction. Therefore under root 5 minus under root 2 is an irrational number. This is how you can show difference of two irrational numbers is irrational, sum of two irrational numbers is irrational. So for this question, especially when we have two irrational numbers, you will adopt only this method. The first method adopted in the previous question, that was for sum of or difference of any sum of any rational number and irrational number. But if we have both irrational number, then we will use this method, squaring this side and get the rational towards rational and irrational on one side, and you will see that the statement is contradicted. So you say that this one is not a rational number, means irrational number. So in this lecture, what I have told means you will solve the question from exercise. Very few questions are very simple questions. Exercise 1.4 of NCERT, you will see in that exercise you are given two questions or three questions. In question number 1, different rational numbers are given and you have to identify whether the given rational numbers will give the terminating decimal or not, and if it provides the terminating decimal, you have to convert them into decimal. So you will solve all those questions by yourself. In the previous exercise, all these questions are this kind, means you have to prove that under root 5 is irrational number, sum of or difference of two rational and irrational numbers. So you can try yourself. Now this is all about the real numbers, but many more questions which are very important for the examination purpose, and this is not given in NCERT. So I would like to solve those questions also, but in my next lecture. Please see me in the next lecture. Thank you very much. Finally, what we conclude the topic. See, I told that properties on rational numbers means operation on rational numbers, operation on irrational numbers, operation on rational and irrational numbers. So I am writing all these things. See, rational plus rational, I am writing in short. Is it okay? Rational plus rational is rational. Rational minus rational is rational. Rational into rational is rational. But rational upon rational is rational. All these things are rational. Now for irrational, see, for irrational I am writing in short. Irrational plus irrational is irrational. Now irrational minus irrational is irrational. Irrational into irrational is irrational for different numbers. For different numbers. Now irrational divided by irrational is irrational for different numbers. For same irrational numbers, for same irrational number, product becomes rational. For same irrational number, quotient becomes rational. Now finally we come to one more thing. When we are given a rational and irrational, then what we have? See, rational plus minus irrational. I am writing both plus and minus, means rational plus irrational or rational minus irrational is irrational, or we have rational into irrational is irrational, and we have rational divided by irrational is irrational. Means any operation when we adopt with rational number and irrational number, result is always irrational numbers. So you may go through it, understand it whenever you get the result, and whenever you are identifying the result, you will see that this result is according to this. Means you have to learn it. Thank you very much.